My name is Parag, and I'm the co-founder of this company. My company's name is ARC Educators. We are doing this stargazing astronomy program from last 8 years, and specifically, like from last 5 years, we are doing in schools. Okay, we take school kids for stargazing programs. The all the dots which you see are basically galaxies, not stars. So now these galaxies have like billions and trillions of stars. And one important and interesting thing of stars is like stars have a lifetime, like we humans have. Like we born, then toddler, then we go to school, and then we go for college, job, then we get married, and one day we go back to Godhead, right? Similarly, these stars has a life cycle, okay? And then eventually we won't go in detail understanding of how that star life cycle is happening, but we'll surely are going to see what are the end stages of a star, okay? One of the end stages is obviously the black hole, which is our main topic for today. So now this star life cycle is also called a stellar evolution. Stellar evolution is the process by which star changes over the time. So we will be seeing few stages of that star, okay? And the main criteria for the death of a star, like how it is going to be. So depending on the mass, you can see the table. It says that mass in the bracket, it says solar masses. One solar mass is equal to mass of our sun. Okay. So solar masses means one solar mass. Okay. Now you can, as you can see in the base, it says 0.1 solar mass over here. It will take a thousands billions of years for the lifespan. Okay. It has mass equal to 60 solar masses or more than that. It will consume its fuel very faster. So it will die very faster. So the age of that particular star will be around 3 million years. Okay. Like as I told you, we are going to understand the life cycle of a star. So I'll show you one picture and I'm going to explain you each and every part very briefly so that we can go ahead with our presentation. Okay. Okay. The first part is the molecular cloud. It's basically the gas and dust cloud, which you will see across the universe everywhere. It is made up of basically hydrogen gases. Now, what happens is because of different things, these hydrogen gas come together and then they make the first star, the base of the star, which is also called as protostar. Molecular cloud is also called as a nebula. Okay, this is the picture of the nebula called Orion Nebula. Everyone must have heard about this Orion constellation because that part, I'm going to show you one interesting video as how protostars actually born. Okay. Okay. So this is a computer simulation as how actually stars born. Okay. I'll just make it full screen and play. On the top right side, you will see the year, the time from the like the gas nebula structure, how stars, how much time it takes. And the left side top corner, you will see the distance from what distance we are seeing it. Okay. Now you will see three stellar structures. You can see time on the top of the top right corner. Okay, like how much time it takes. It started around 48,000 years and now it's around 2,44,45,000 years. So this is the computer simulation that is why we are seeing in fast forward. Otherwise, it takes millions and billions of years to create a star. Just make sure you see all those small dots also. See some of the dots, like they flew away out of that gaseous structure. Let's see. So now those dots, these dots are the protostars that we saw over there. Okay. And some of the dots, they actually can't make it to the star. We will go first down the line over here. Can you see the brown dwarf? These brown dwarf are not the stars and they are not the planet. They are like in between. They don't have enough gas so that they can become a star, but they have higher mass than the planets like Jupiter. So throughout the time, like throughout the lifespan of theirs, they just stay unidentified, okay, because they are not emitting any light, so we can't see them. The second part is the low mass stars, which are over here. Low mass stars is basically the stars which has, mass lesser than 8 times mass of the sun. So consider our sun has weight 1 kg, okay. So if a star has weight less than 8 kg, it will become a low mass star. And few stars which have gathered very huge amount of dust and gas, which has weight more than 8 kgs of sun, they become massive star. Okay, let's go one more step ahead. We will just basically understand what happens in this star. Those hydrogen gases come together. It's called a fusion reaction. They generate heat. That heat comes to us. Third thing, because they have so much mass, they have gravity. Is that much okay? Everyone? Three things. Hydrogen gas. So now what happens is, let's go to low mass stars over here. When they use all their hydrogen inside, okay, the outer layer starts to expand. As it expands, it becomes a red color. So it's called red giant. Now, this red giant, when blast, two things will happen. One, it will become a planetary nebula. Planetary nebula means the area from where our planets born. And the second thing is, consider there are two stars going around each other, and one has become red giant. Can you see this part? One has become red giant,
Yeah.
and the other one has become the end part of the star. One more thing happens, which is called a supernova. Now, before we go to the supernova, let's understand what happens inside the planetary nebula. So when that outer layer expands, sudden blast happens inside the core of the sun, and the core of the sun is collapsed, like very sharp. The density is increased. If our sun is going to die, the outer layer is going to expand, and the inner core is going to collapse and becomes a white dwarf. Okay, that's the first end stage of a star. Let's see what are white dwarfs. White dwarfs are basically dense stellar corpses. They are basically made up of oxygen and carbon. Okay, and 97% of the stars in the Milky Way are going to become. A very interesting thing about the white dwarf is, if I just go and collect one spoonful of dust of white dwarf, it will weigh around 5.5 tons. That means the star which is dead, which we know as white dwarf, which look like a white color star, it is hot enough, but its density is so much that one spool of dust, 5.5 tons. It's a huge amount. Yeah. And their size is very small. So can you see this right side picture? There are two things. One is big star and one is that dot. Can you see that dot with the arrow?
Yeah.
That arrow is basically the white dwarf. These are two stars. They're orbiting around each other. Okay. One has become white dwarf. That means that star is dead, and the other one is still alive. Okay. Now what happens is this part. When one is white dwarf and the other one is already a kind of a big star, this white dwarf is going to, try to pull all the dust and gas from the live star. What will happen is, white dwarf is already dead. I'm considered a white dwarf. I'm pulling all the gas from my partner. Okay. It will eventually come to me and it will happen a big blast. That blast is called supernova. Okay. In that supernova, basically, that star is going to blast. Even white dwarf is not going to stay there. This big star is called Sirius A, and its companion, the white dwarf, is called Sirius B. Okay, the brightest object, or you can say the brightest star after sun, is this star, Sirius A. And the next one is Sirius B. Let's go ahead. I was about to tell you about the supernova. Now, this is very interesting thing. The presentation is not working. I won't be able to show you the GIF. Now, the interesting thing is, there is this one star is appearing in these three pictures. Basically, this is the combination of three pictures, like one by one we have superimposed, and you can see the star is appearing over here. It's not basically a star, it's a supernova explosion. As I told you, this supernova explosion is basically a very violent thing which happens in the universe, and it's very rare event. Okay, Galaxy has billions of stars. Only one star is blasting, still the light is so much. So that event is very, very violent. Okay. When the massive stars die, they become a red supergiant, not red giant, but red supergiant because they are massive star. It becomes supernova, and then supernova remnant happens like this. And in that supernova remnant, we have two different kinds of death stars. So this is the supernova remnant that has happened. It is also called as Crab Nebula. And our next thing is going to be the neutron star. Okay, this is the second kind of dead star that we see throughout the space. Now, how does neutron star come in the space? Okay, what happens is bigger the mass, more gravity, more collapse, more smaller the core. Okay, as you can see, but a neutron star, consider if a massive star is blast in supernova, a neutron star, the remnant in the core is going to be of size of a city. For an example, just between 10 to 25 kilometers. Mass of a huge star concentrated in that particular small area. That is why it is so dense. So it will have immense gravity and immense electromagnetic field, or you can say magnetic field. Okay. Again, very good, interesting thing. A teaspoonful of their matter would weigh around 3 billion tons. Let's see the next slide. It says it is a great amount of matter packed into a very small area, smaller than that of a neutron star. Third stage, you can say a third stage, a third type of death that a star can have. A very massive star, which has a very mass, like a very huge amount of dust and gas, and then they collapse in very small, tiny amount. It becomes a black hole. We will see so many different things, some interesting things. It says the result is a gravitational field very strong. Someone was just telling me right now. The fourth point is very interesting. A black hole is then defined as an object with a radius equal to or less than the Schwarzschild radius. I'll show you Schwarzschild radius in next few slides, like after third, fourth slide, three, four slide, I'll show you what is Schwarzschild radius. But before we understand the Schwarzschild radius, let me tell you one interesting concept. There is something called escape velocity. So for an example, escape means to go out, velocity means the speed. Okay. So if I just want to go out of Earth's atmosphere, Earth's gravitational field, I will be needing a speed of 11.2 kilometers per second. But if I want to overcome black hole's gravity, wherever you go, light has the maximum speed. It is 3 lakh kilometers per second. 1 second, you have to travel 3 lakh kilometers. You need to have speed more than that to overcome black hole's gravity. If you have that, then you can come out. Otherwise, you can't come out.